Welcome to the Special Forces in World War II YouTube channel created by the Special Forces in World War II team.
They could make these stones float if they wanted them to. They could make this rock float. Even this Sherman tank could be made to float. The question is, how? The upward force exerted on a solid object immersed in water is equal to the weight of the volume of water displaced by the object. If this force is greater than the weight of the object, that is, if the object possesses less density than the water, the object will float, with more or less of its bulk projecting above the surface. If, on the other hand, the weight of the object is greater than the weight of the water displaced, the object will sink to the bottom. By increasing the volume of the water displaced, however, by building projecting walls on the object and hence increasing the upward force, even the heaviest object may be made to float. And that's the principle by which the Sherman can be made to float. A canvas screen is fitted onto it to give it the necessary buoyancy. To carry this screen and to get volume, a false prow and all-round decking are built onto the tank above the tracks. The screen frame consists of pillars inflated by an air compressor driven by the engine. These pillars are attached to the false prow and decking. Stiffening rails are in turn secured to the pillars and also struts secured to the tank hull. Canvas is fitted to this framework. While waterborne, the tank is propelled and steered by two propellers driven through the rear idlers. The screen is collapsible. It's raised by the air pillars and deflated by hydraulic means, which also break the struts. The following sequences are carried out under training conditions and will vary according to weather and ops. When the tanks are used in a sea operation, they are loaded onto a landing craft from which they are launched at sea at a given rendezvous. Loading is done in reverse, with the tank commander facing the landing craft so that he's in visual contact with the loading officer. Special care must be taken to avoid damage to the flotation gear. When the craft is loaded, the ramp doors are closed. The standard Mulock extensions remain fitted to the ramp and are packed up to the same plane as the ramp, which itself is not long enough to be used as a launching platform for the Sherman DD tank. If the extensions were not packed up, the bow of the tank would drop too steeply when entering the water. Half an hour before the rendezvous is reached, the tank crews start preparations for launching and carry out a drill to check over the equipment. The propellers are checked for lowering and raising, and at the same time the hydraulic steering gear is tested from port to starboard. The waterproofing is also inspected. When the final checkup of all equipment has been completed, the engine is started to raise the screen. During the inflation, which takes about 15 minutes, the crew fit on their Amphibious Tank Escape Apparatus. Each man then reports to the launching officer, who inflates the escape apparatus with oxygen. When the screens are fully raised and struts made, inspection is carried out by the crew to see if any tears or damage have been sustained during loading. Repairs can be made on board. The deck steering levers and the driver's and commander's periscopes are now placed in position. The landing craft has now reached its rendezvous. It should have its stern to the wind so as to give as much protection as possible to the tanks as they enter the water. The ramp is lowered to the limit of the preventer chains. These are checked by the launching officer, who sees that they are fully extended, because they must take the whole weight of the ramp, the lowering cables acting as an additional safety measure. He also makes sure that the ramp is at an angle between 18 and 24 degrees to the deck, with the hinge pins flush with the water. The position of the ramp is of the highest importance for safe launching, and it is the responsibility of the launching officer. The readiness of the craft for launching the tanks is the responsibility of the senior naval officer, who can stop the launching if at any time he considers his craft is being endangered. The whole time he keeps in visual contact with the launching officer, who stands on the starboard winch house so that he can be in contact with each tank commander. The tanks are put into first gear when they're launched with their propellers raised, and on no account must the steering gear be touched while they are going down the ramp. The total weight of the Sherman tank is 34 tons. Immediately the tank is waterborne, the commander orders the driver to lower the propellers and engage third gear. If any water is shipped or seeps inside the screen or hull, it's cleared out by a bilge pump. The entire tank is below the waterline, which is approximately level with the top of the turret. As she goes along, the tracks revolve in order to drive the propellers. She's steered by the commander using the deck steering lever, but if enemy action forces him to close down, the driver steers with the aid of his periscope or by directional gyro. Or, as the commander also has a periscope, he can give instructions to the driver. In water, the Sherman can travel at 4.24 knots, and her fuel consumption is 25.26 gallons per hour. Small arms fire has little effect on the flotation, but a near miss by HE may damage the canvas below the waterline. However, unless the screen is badly torn, the bilge pump can deal with the incoming water. As the first three tanks touch bottom and come up to the beach, they may take up a hull-down position in the water by deflating their screens to the half drop at the rear. This prevents a following sea from swamping the engine, and the armament is now ready to engage any target. The remaining tanks come ashore and go into the full drop position. Once the tanks have beached, they take up their normal role of fighting vehicles. Their performance and maneuverability on dry land is not affected by the fact that they've swum ashore under their own power.
Thank you for watching the Special Forces in World War II YouTube channel, an unwavering digital fortress committed to preserving the history of elite and specialized units in World War II. Our mission is clear: to provide a comprehensive view of the elite units and formations that played pivotal roles in the Second World War. This extensive dossier includes their frontline battles, innovative weaponry, strategic maneuvers, and the brave soldiers who faced the crucible of combat. The World War II SOF Virtual Museum is our dynamic field operation, continually uncovering layers of historical knowledge. We also maintain outposts on Facebook, Instagram, and YouTube to enhance our information dissemination. If you possess relevant intelligence to support our mission, don't hesitate to share it with us. Your contributions will be prominently featured in our operational archives. For those willing to provide substantial support, visit our Patreon forward base and enlist. Your backing is crucial to sustaining our mission. Together, let's carry forth this legacy.